please.
Yeah, that's okay.
Which one?
No, just this only. I just want to look at it once. Take a screen grab and try it later. Thank you. Done.
This one?
The upper code. I've already taken it. Means I copied it already.
Oh.
I
It's
just
simple.
try it later.
I tell you one thing. Actually, I don't use this one. AX1 kind of things, AX2 kind of things. I rather go for plt.scatter. I'm not so much comfortable with this kind of things. Figure equal to plt.figure. Actually, figure is a kind of object things. There are two objects. Ax dot figure, x comma figure equal to plt dot figure. But I am not so much comfortable with this one. I always go for plt dot figure. But since I got the code like this way, so I copied it this way and implemented. Because my object is that to represent. I was giving one talk somewhere, and my object was to see how properly the transformation is taking place and how can visually check it. Now that was done by just looking at the color codes. All the color codes, you can see that they are quadrant wise, they are coming in the perfect way.
Beautiful. Okay, thank you.
Okay. Then there is another important feature in this sections, that is subplot. Sometimes it so happens that you have to plot several figures in one frame. Say for example, Lissaj's figure. For example, for different phase angles, depending upon the phase angles between two vibrations, it will be either straight line, linear motions, or circular motions, or elliptical motions, like this. So if you want to display that feature, then 8 features or 6 features you want to put it in one frame blockwise, then you have to use subplot command. How does it look like? This is probably, if you want to show your features like this way, that is for phase difference between two vibration. If it is 0, it is a linear motions. For 45, it is elliptical, like this. So for this kind of representations, you have to use subplot command. That is, in the subplot, this one, in the subplot, plt the subplot, you have to define how many rows are required, how many columns are required, and how many figures will come out in the way. So the first one represents, I have written over here, the plt dot subplot within bracket row numbers, column numbers, and figure numbers. If you give it, and once the figures are generated, then they will be placed accordingly, and finally you will get an output like this. So if you try it out for different other problems where this sort of representation is required, you will get a nice output. Now I take a real problem, that is a problem. Someone has asked me whether I can import some data file in the problem and give a visual representations. Who is that? Somebody has put this question sometimes back.
Yeah.
Debargo Goswami.
Yeah.
Okay, now here is your answer. See, this is a problem. I have taken one famous book which I particularly follow, that is Computational Physics by Mark Newman. This is a very nice book, very simple books for at least for physics purpose, computational physics purpose. What about the problems that you face in physics, and if you want to solve it through numerical way, this is a very nice book. I always follow it. There in this book, there is a problem. The problem is like this: the data. There is a famous experiment by Millikan's experiment to verify the photoelectric effect. You know it better. So the experimental data is stored in a data file called millikan.txt. That is also available in the net. One can download and you can verify this one. This is taken from a historic experiment by Robert Millikan that measured the photoelectric effect. The data in the file, that is millikan.txt, represent frequencies in hertz in the first column and voltage V in volts in the second column from photoelectric measurement. My data is like this one. Now, how to import a data file and use it in your program? This is the simple syntax. That is, from NumPy, you import load.txt. This is a file that will do the job for you. What you have to write, load.txt within bracket the data file. My data file is millican.txt. So millican.txt, and it is of nature float. So if you write it, your data will be it will be imported, and it will be stored in the variable called data. Let us check it out, how step by step. So what I have done, first of all, I have to import my load.txt functions from NumPy. I have to write load.txt within bracket my particular data file millican.txt. Its nature is float, and I want to extract it and put it in my variable data. After that, I want to see what data exactly it consists of. It is having two sets of data. This is one column, this is another column. It is said that the first column represents frequency in hertz. That means all these represents frequencies. And the second column represents voltages. These are voltages. So once I got this information, then I have to arrange my data accordingly. So what I will do, this is not a nice way of doing these things. So I have told you, first of all, you convert your data into NumPy array. So from data is now in the form of an array that you can see. Output is coming array like this. Now, how to extract the first column? The data extraction for the first column, that means all the rows will be taken into account. So all the rows, and the first column means 0. So if you write this command, this stands for all the first columns. And if you write 1, it is the second column. So first column represents your frequency, and second column represents your voltage. And Python has a very beautiful features. If I write new and v, it will understand that new stands for this first one, v stands for the second one. And after that, if you write new, it will give the result like this. So from it is giving a better understanding. What is new? New, you understand it is the frequency, v, it is the voltage. Now you work it out. This is what exactly I did.
So, is it required to prepare the data file in any particular format? I mean, what is the difference, the gap between the two rows, or whether it should be separated by comma or something?
CSV file, that is comma separated variables. CSV files are can be imported, because I have done in one of my research work. My files were in the Excel, and
Okay.
I have converted into CSV. Excel files also, data files also can be taken. I can import it in my Matplotlib Python. I used at that time this one, Panda.
Okay.
Panda package is there that absolutely are dedicated for handling large data files. So there are different techniques. You can import your data files into Pythons, and you can subsequently carry out all your analysis through NumPy and other kinds of things. This is my personal experience. That is quite possible.
Okay.
So you have prepared your data. So this is what I've done. Now you plot new against v. This is the plotting. Or I can do it from the very beginning. A straight line, but I don't want straight line. What I want is that I want only the experimental points to be shown over here. So simple way you can do it. Starts, or if you don't like starts, you can put O till go like this. So these are your experimental points. And if you want that, you want to make the points little bigger, or little more. So this is how you can always manipulate. So this is the nice representations. These are this is along x-axis. This is, so how can you understand what is there in the x-axis? plt.x level. plt.x level. What is there in the x-axis? It is new. So how will write new? I will take use of LaTeX. And along y, v, simple v, but still I want to put it in a symbol form. So without symbol it can be done. Oh. Okay, fine. What actually this points represents? I have not said anything. These are experimental points. Later you will have to see it. So I have to put label over this one. Experimental data reader. And once you have put the label, you have to show it. So it's a perfect representations. So this is what exactly I have done into here. This is the kind of things. Oh, I have not done completed it anyhow. So next problem is that I have to. Yes, who is there?
Yeah, regarding the importing the files, so the files has to be in the same directory, or we can load from other directory also, like load.txt.
Other formats, I have told you, you can make use of
no,
your...
not formats, means, no, sir, that means my file is in some other place or directory. So how will means load this file?
You have to define the path. You have to define the path.
Right.
There, okay? You have to define the path. And load.txt is not always so much helpful. It is for preliminary academic purpose, it is all right. But if you are doing some research work, and if your file is somewhere else, either in the CSV format or in the Excel format or other format, Panda takes good care of this one. And you have to write the path properly. This helps there in the internet, you can find if you search it.
Okay, thank you.
Excuse me, sir, there is a query.
Yes, please.
Poonam Jain. Yeah. Sir, I wanted to ask, while drawing this graph, if I want to write some text inside it, for example, if I want to mention about the heading of the graph, the graph is versus which to which, right?
Okay, just,
or some explanation about
just look at my window. I'm doing it. I've skipped this part.
Okay.
What title you want to give? Suppose photoelectric effect. It has come. Can you see it?
Yes, sir. Yes, this is what I want. Yes.
plt.title.
Can we do it in the this thing origin as well?
Origin?
Yeah. While plotting the graph using origin software, can we do the title?
I don't have so much good idea about origin because I have not done it in origin.
Okay, fine.
Excuse me, sir. Excuse me, sir.
Who is there?
Hello.
Who is there?
Madam, you also. Yes, sir. Raja, I am Raja.
Okay, please. Raja.
Madam, also you also, as you tell about origin. Actually, sir, origin. I also want to ask. Sir, hello.
Please carry.
Actually, origin. I am from chemistry background, right? Though some physical chemistry work was there, like surface tension, conductance, and lots of physical data was there.
All right.
So Origin is a very good scientific software.
Yes, yes, yes.
We can. It is quite user friendly and quite updated software. And another advantage, if anyone in the first stage, if anyone have feel difficulty to use Origin, it have one option that one can go to the Excel part of the Origin also.
Yes, yes, yes.
Means I also have some questions like Python here. When I'm plotting the things, means Origin we are quite accustomed, quite we are familiar. So then we only have to compare, means by Python which is time consuming or which is time saving or which is more is that we have to only do actually. Then only we can give the better
you say,
feedback.
in short, I can respond it like this way. Let's see, Origin, sometimes it is not proper for me to say I've never seen it or I have not done it. One or two occasions I've tested it, Origin. But Excel, I've done a lot of kind of things. So there is similarity between doing the things in Excel and Origin. And I've also the experience of doing drawing the graph in Matplotlib under Python. One thing I'm telling you, it depends upon your comfort levels. Excel is good in its own way. Origin is good in its own way. What type of applications you are doing? Python or Matplotlib is having its own advantage and comfort zones. So, for example, I'm doing some calculations. Say some numerical analysis. I'm simulating a projectile motions or say simple harmonic motions. So when I'm doing this sort of simulations, I'm making some programs. So program is giving some output in the form of data. So it is the advantage that in the same platform, I can draw the graph by importing Matplotlib. So I'm always comfortable in doing this. So comfort level, it increases more and more you use it. At this moment, I don't think that Matplotlib drawing is hazardous or something not like this. I'm quite comfortable with simple kind of plottings.
Yes, sir.
So but it depends upon how you are using the whole things. What is your applications?
Yes, sir. But it is quite similar to that, sir. Python, that graphical part, that plotting of graph, quite similar to.
So moving forward. So this is the photoelectric experimental data I have plotted. Now I want to fit this data. So I have to make a least square fitting. For least square fitting, you know that a straight line, it should look like y equal to mx plus c. And these are some of the formulas that is always available in the book. So m is given like this, c is given like this, and the individual quantities ex, ey, exs, these are defined like this. Those who have done this straight line fitting, they are quite familiar with this kind of formula. Now, with the experimental data that is available with me, which I extracted right now, I have shown you nu and v. Nu is my x and v is my y, and I have calculated individually ex, ey, exs, and exy. Now, if you ask me to explain how I have calculated all these things in one line, so because I have the experience of doing the same problem in Fortran and basics and other programming language also. Each line, it requires at least 4 or 5 lines to implement in Fortran or some other language. I have also done it. But in Python, particularly NumPy, when I'm making use of array, I can do it in one line. What I have done, what exactly tells you ex is equal to 1 by n summation xi. So summation xi means you have to take sum of all individual values of x. So all individual values of x are stored in an array. My x is nothing but new. New is stored in an array. So if I call the array new and put the command np.sum, so np.sum array new, it will sum all the elements of the array new. Then I have to divide by n. N stands for what? How many number of elements are there in the array? There is a function called len. Len stands for it counts the number of elements. So len within bracket data, that will give you number of data points in this array. So sum divided by n, that is giving me ex. Similarly for y stands for voltage. I saw voltage here. So v array is there. So np dot sum v, that is giving me sum of all the voltages divided by numbers. exx, you can see it is sum of the squares of the elements. So sum of the squares of the elements, new is an array. I am taking the square of every elements that is done in the numpy. If you write the array and make it squares, it will take care of every individual array elements and square them. Then I'm taking the sum and dividing it by len data, that means n. For xy also, I'm also doing new arrays there, v arrays there. If I multiply it, then element to element multiplication will take place. I'm taking the sum, dividing by len. So in just 4 lines, I'm doing all the calculations. Then I'm calculating m and c by this formula, m and c. So I have got it. I'm printing the result. My m is this one and c is this one. So I want to now fit the voltage with the known values of nu. So it should look like v fit is equal to m multiplied by nu plus c. And I want to plot now nu against v and nu against v fit. And these two graphs, I want to plot it in the same window. So this blue dots are experimental points and fitted line is like this one. So my fitting has been also done. Now from this equation, if you compare y equal to mx plus c and already established photoelectric equations, which is something like this, my m gradient of the line is equal to h by e. So if I compare my gradient with h by e, then e is equal to h by m. H is your Planck's constant. So if you put the value of h and gradient value, which you have got it from this fitting, which is this one, then you can get what is the charge of the electron. So charge of the electron is something 1.6 like this, 10 to the power minus 19 coulomb, which is, is the charge of the electron. So this is a very simple exercise. This shows you that you can bring one data file, a data file which corresponds to some famous experience of some of the scientists. You can plot in your notebook, you can verify the data, you can fit it, and you can establish, verify some of the physical constants which you have done in the photoelectric effect here. So this is one example. So, Kullan, can you hear me?
Yes, I can hear you, please.
How much time is left now?
This will last up to 1 p.m. This program.
1 p.m.
This session.
All right. So before 5 minutes, you just remind me, okay?
Okay.
So let us take one more example. That is an example of sunspots. So this is a problem, we have got it from the Mark Newman's book. The earlier one was also from Mark Newman's book. So you will see that we have got a text files of sunspots, which contains the observed number of sunspots on sun for each month since January 1749. The file contains 2 columns of numbers, the first being the month and the second being the sunspot numbers. So you have to write a program that reads the data and makes a graph of sunspots as a function of time. This is the first problem. And the second one is that you modify your program to display only the first 1000 data points on the graph. And the third problem is that you modify your program further to calculate and plot the running average of data. So sunspot data is there. I have imported the sunspot data, which I have done it earlier also. So I have shown it. The first column represents month, second column represents sunspots number. So I have extracted the data and I extracted it for month and sunspot number. Now I want to plot it, sunspots number against month, and I want to plot it like this. Let us see how does it look like. So this is the output. So against each month, sunspot numbers are varying like this way. This is the simple representations. Now, second part of the problem is that modify your program to display only the first 1000 data points. So first 1000 data points, how will you extract? All right, let us restrict it to this one. Some I want to send it. Intentionally, I don't want to take this problem at this moment. For the problem 2 and 3, I want to send it as an assignment. Okay. The next one I want to display is the curve plotting. Okay, this is another one. Let us get us accustomed with this one. Suppose you have a curve like this. Make a plot of the so-called deltoid curve, which is defined parametrically by the equations. So here there are two parametric equations. One is given by x equal to like this in terms of theta, and another is equation y in terms of theta. My theta values are in between 0 to twice pi, and we want to set the theta values between 0 to twice pi and like this. Taking this approach set up further, that the first line is that what I will do, I will create values for theta by linspace command, and I will evaluate x and y for each values of theta, and I will plot x and y. What is the result? Let us see it. So this is the result. So you can reproduce your graph. If there are two parametric equations like this and theta values are given, then you can reproduce your graph like this way. The next one is that polar forms. So for polar graphs, you have to just put the command plt.polar theta values against r values, and you can put the polar graphs. This is the spiral graphs between x and y. Now, next, this one is another one. The third one is solid. All right. I don't know why it is giving so much trouble at this moment. All right, let us go to the next one. So this is another problem that is very nice problem. It is a problem regarding Hertzsprung-Russell diagram. So it is a, in an ordinary graph, there is one independent variable, one dependent variable. Why it is very important for me to discuss scatter plot? When we are actually going for scatter plot, this is important. Generally, what happens for one independent variable, we are calculating another variable that is dependent one. And the graph is a visual representation of the variation of the dependent variable as a function of independent one. For example, voltage as a function of time or temperature as a function of positions. But sometimes so happens, if we measure two independent variables, say for example, temperature and brightness of stars, the standard approach to visualize the two quantities is to use a scatter plot. That is why I have included this problem in my lectures. When you have two dependent variables, and then to compare these two dependent variables, you are advised to go for scatter plot. Now, here is an example. The example is that there is a data file called stars.txt. This data file contains temperature and magnitude of brightness of a set of stars. The first column represents temperature and the second column represents magnitude of brightness. So if I have to make a scatter plot of this data, then how does it look like? So I've extracted my data and I've extracted my X and Y values and I've put a scatter plot like this. The command is that earlier we have done it plt.plot, now I have to write it plt.scatter. This is the only difference. And two dependent variables, so you can write it serially X, Y, and you can give colors. But other part, X level, Y level, limit, etc. remains as it is, like we have discussed earlier. So this is the output. So X-axis represents temperature and Y-axis represents brightness. And if you put a scatter plot, you get a visual representation something like this way. Now, here one thing you can see, the temperature has been represented from minimum to maximum, and brightness are also accordingly like this. Now, if you want to reverse it, that is, I want to represent my data in such a way that temperature is shown from maximum to minimum, then how will you do it? So I have to make a little modifications in my program, that is, I have to put X limit max X to minimum X and Y limit max Y to minimum Y. So this is the simple modification I have to make, and then I will get the output what I want. So now temperature starts from maximum, goes up to minimum, and accordingly brightness is going like this way. This is your Hertzsprung-Russell diagram. This is the standard way of representing the star's temperature and brightness comparison. Now, another thing that I want to show you, that is called density plot. Density plot is something like this.
Hello, Subhita. Hello.
Yes.
Okay, the time is too short, so maybe we can take 15 or 10-15 minutes from the that means of the next session. That
actually, I'm telling you, yeah. I have only density plot is left behind,
okay,
and scanning channel. These are not so important at this moment. So I don't know whether within 2 minutes we can finish. I think we can do it very fast if I go very fast.
Okay, I have already scheduled. If required, also we can go for that. I have already scheduled another meeting.
All right, thank you. So what exactly is density plot? That is very interesting. For example, variation in charge or temperature or atomic deposition on a solid surface, the heights of waves in a ripple tank, the distribution of particles incident on an imaging detector, and so on. These are represented in a two-dimensional grids of data. So when you are representing a two-dimensional grids of data, sometimes this sort of density plot is very necessary, and it is very effective to make a visual representation of data points. So what we do here is that, suppose I have a forget it. This I want to skip this, but let us go for this one. This is very important phenomenon in physics, that is wave interference. Suppose you have a pond. Suppose you have a pond of certain dimensions, Now, if you drop a pebble somewhere, then waves will be moving around these pebbles. Imagine that there are two sources of disturbance, one here, another here. Then from these two disturbance, spherical waves will be spreading around all this way. And in this way, there will be interference between the two waves. So within this spawn, you will get some interference pattern. Now, my intention is to simulate this kind of interference pattern that may take place if you drop two pebbles nearby and there are two sources of waves. And how the interference pattern will look like if I plot it in density plot. So for this purpose, what I have done,